In this video, I'm going to show you how to create a do-it-yourself ultraviolet disinfection box that you can use to sterilize medical masks and equipment and help fight coronavirus. You can also use it to clean other stuff too.
Hey YouTube, I'm Dr. Mike Itagaki, an interventional radiologist in Kirkland, Washington. You may recognize Kirkland as one of the epicenters of the current coronavirus outbreak. Now, for our hospital and other hospitals that are battling this pandemic around the world, there's an acute shortage of personal protective equipment, or PPE, particularly masks. And in this video, I'm going to show you how you can build an ultraviolet light box to sterilize used masks or other contaminated equipment. This can be done with materials that you have lying around your house, and the total cost of the project is less than $120. Now, these types of masks are designed to be worn one time and discarded. And the reason is, if you inhale and breathe infectious particles and they become trapped on the mask, then those particles can still potentially cause infection. You could touch the mask and then touch somebody else uh, and spread infection both to another person or to yourself. Or, I guess in theory, you could cough or sneeze, or by breathing, the little particles could come out. So if you go to a different patient room wearing this mask, there's a potential to spread infection. Now, unfortunately, because these masks are in such terribly short supply, healthcare providers have had to reuse them. And not just reuse them a little, but reuse them a lot.
Reports locally and around the country and world indicate that reuse of masks among healthcare workers has become necessary due to shortages, with some workers sometimes using the same mask for as long as a week. To start this project, I got a regular cardboard box that I had lying around the house. I wanted something that was big enough for me to fit a bunch of masks in, so I used this box for my shop vac. I started by completely taping the box shut on all sides. I then cut a flap open on the front with a box cutter. Next, I lined the inside of the box with aluminum foil and used Gorilla Glue to keep the aluminum foil in place. I did this in sections, and this took a while because I let the glue dry completely before moving on to the next section. Next, I mounted this ultraviolet lamp that I bought on Amazon. I will put a link in the description. This lamp is designed for HVAC units, and it shines ultraviolet light inside to prevent mold from growing on the damp condenser coils. It cost about $99 on Amazon. I cut a hole in the side of the box and mounted the lamp inside using machine screws and some washers. I glued a Velcro strap on the door of the box so that I could easily open and close it. Then I gave the box a nice paint job. Finally, I put some basic warning labels on it that I printed up. Ultraviolet light is a high energy light that human eyes can't see. Not all ultraviolet light is the same. The wavelength goes anywhere from 10 nanometers to 400 nanometers. UVA, or long wavelength ultraviolet, is used in things like black lights. UVB, or medium wave ultraviolet, is what makes vitamin D in your skin. Shortwave and high energy UVC is germicidal and can break up molecules such as DNA. Now, this can cause damage to your eyes and skin, but it can also destroy the DNA or RNA in viruses. Surprisingly, this type of ultraviolet light is made from common office fluorescent lamps, but these lamps are coated with phosphors that absorb the ultraviolet light and re-emit it in the visible spectrum. Fluorescent lamp makers go through great lengths to make sure that the ultraviolet doesn't escape and cause harm to the people in the office. Germicidal ultraviolet lamps are essentially the same as regular office fluorescent lamps, except they don't have the phosphor layer and are made of special glass that actually allow the ultraviolet rays to escape the lamp. This can be really helpful to us because we can use these germicidal ultraviolet lamps to help kill coronavirus and sterilize our N95 masks. One of the problems I had is how to efficiently fit N95 masks into the box. I wanted the masks to be evenly distributed so that they would receive light on both the front and back surfaces. To achieve this, I created a stackable, modular 3D printable rack system that can be adjusted and used for boxes of varying sizes. This rack is a pretty cool way to mount N95 masks inside the box, and if you have a 3D printer, it is pretty cheap and easy to print. It took me 12 design iterations to get things just right, so I'm pretty happy with it. I'll put a link in the description where the files can be downloaded for free in case you want to 3D print your own racks. If you don't have a 3D printer and want to order the racks printed for you, you can also do so at the link. So how much UVC ultraviolet light is required to kill coronavirus? Well, nobody's actually done a study with the current coronavirus, which is called SARS-CoV-2. There is a very similar virus, SARS-CoV-1, that caused the SARS outbreak in China in 2003. This virus is also in the coronavirus family and is very similar to the virus causing the current outbreak. A lot of research has been done with this virus, including studies on how to use ultraviolet light to sterilize blood that may have been infected with SARS-CoV-1 in blood transfusions. This paper, from a transfusion medicine journal that was just published, found that 0.1 joules per square centimeter of 454 nanometer UVC energy was sufficient to reduce SARS-CoV-1 coronavirus to undetectable levels. For this project, we're going to use that as our best available proxy for the current SARS-CoV-2 coronavirus. My box has dimensions of 20.5 by 14.5 by 17 inches, or 52.07 by 36.83 by 43.18 centimeters. That gives it an internal surface area of about 11,513 square centimeters. My ultraviolet lamp has a power output of 30 watts. Assuming that the light is evenly distributed around the internal surface of the box, the coronavirus germicidal threshold of 0.1 joules per centimeter squared should be reached in about 38 seconds. Of course, when masks are put in the box, there's going to be greater surface area, thus increasing the amount of energy we need. However, the reflective aluminum coating on the inside of the box will reflect light around instead of absorbing it, thus decreasing the amount of energy we need. Another factor is there are areas in the box that would not be illuminated evenly due to shading. Also, the surface area of the mask is not smooth. It's made of fibers which have lots of nooks and crannies, and that increases the surface area. It's hard to account for all these variables, but I figure using 5 minutes is a reasonable cycle time, which is about 8 times the required amount of UVC if we just had an empty box. To use the box, put your N95 masks on the rack, put the racks in the box, close the door, and turn the box on. I bought this $7 timer from Amazon and set it to 5 minutes. I'll put a link in the description. Some ultraviolet lamps will generate ozone, which is a component of smog and can irritate people with sensitive lungs. This ultraviolet lamp claims not to generate ozone, but having decent air circulation where you are using the box is a good idea. When the cycle is complete, take your masks out. You may notice that they have a little bit of a funny smell, although they look perfectly fine. This is because the top molecular layers of the mask were zapped along with the virus particles and other germs. The smell should dissipate in a few minutes. You are good to go.
I'd like to say a few things about this project just to be clear. First, this is not an FDA-approved method of sterilizing masks, and I think that should be pretty obvious because we did this out of a cardboard box. Second, ultraviolet light can be very damaging to the eyes and to the skin. It's quite dangerous actually, and you should never ever look directly into the light. And if you are working with it, make sure that you wear UV filtering goggles and appropriate skin protection. Third, I'm not a virologist and I don't have a way to actually prove that the virus is inactivated on the mask when you treat it with the UV. But if you are a virologist and have access to a virology lab and can rigorously and scientifically validate that this works or doesn't, please do so and leave a comment below. Now, I think scientifically though, this is likely to be helpful and it's better than what we're currently doing with our masks, which is absolutely nothing. So that's it, YouTube. That's how you make an ultraviolet sterilization box out of common household materials for less than 120 bucks. If you like this project, give it a thumbs up. If you have some thoughts about it, please leave a comment below. If you live next to a hospital or a healthcare facility that's battling the coronavirus, please reach out to them and consider making a box like this to help them out. I'm sure that if we work together, we can together address this critical shortage of PPE. Finally, on a more personal note, one of the terrible things about this pandemic is that when healthcare providers and first responders take care of coronavirus patients, they can, of course, catch the disease, but they can also bring the disease home to our families. So the virus actually makes us a threat to our own families. And PPE is the shield that not only protects us, but also protects our families from sickness. That's why it's so important. So anything that you can do to help address the critical shortage of PPE is greatly appreciated, not only by all of us, but our families as well.